So let's see. Alicia, you are a senior software engineer, but also have a master's degree in mechanical and aerospace engineering. That is so cool. And you've published research in machine learning and robotics. You started Flipped Coding in 2017 to help people learn web development with real world projects, and it's been growing ever since. In your free time, you spend time with your husband and your dogs while learning to play the ukulele and learning Japanese. That's really cool. Well, welcome. Do you have anything to say? You want to get started?
Yeah.
I got a screen here somewhere to share, I bet.
Thanks for the intro, Lee. I'm super glad to be here with y'all this morning.
Yeah, we are so happy to have you.
So I guess I will attempt to share my screen. All right, I think you can see my screen, right?
Yeah, got it. Okay, do that. I'm getting the hang of this, I think. All right, there we go. Okay.
Okay. So, hi everybody. Like Lee mentioned earlier, my name is Melisha McGregor, and I'm actually a developer advocate at Conducto, where we make CI/CD tools. And you can find me on the internet, mostly on Twitter at Flipped Coding. So today I want to talk to y'all about securing your web application pipeline from intruders. So basically what we're going to talk about is a bunch of tools that you can add to your pipeline to keep things safe. But I always like to give a quick overview of what I'm going to be talking about before I get started, because I know you guys are going to kind of tune in and out as I go through, but I want to make sure you at least catch the parts you're the most interested in. So at first, we'll start by talking about some common best practices in CI/CD. Make sure that your pipelines, all up to date and you don't have any pre-existing vulnerabilities or issues. Then we'll talk about why security gets overlooked in CI/CD. It's just one of those things that we all know should be there, but for whatever reason, it gets pushed to the back. We'll see why, though. Then we'll talk about kind of the interesting part where we learn how intruders actually work. So when they're trying to hack your web application, what do they actually do? And then we'll talk about some things you can do to prevent them from attacking your pipeline. And personally, it always helps when somebody goes through these giant lists of tools when they give an actual example of how you would implement at least one or two of them in something. So we'll go over just a quick example of how you would implement some extra security tests in Sql CI, Conducto, and Travis CI. And then we'll just wrap up at the end with some key takeaways and the main things that I hope you'll take back to your web app and your pipelines. So, first thing, common best practices. We all know that we want to keep our build sizes small, mainly because it makes sure that our builds run fast. And the reason we need fast running builds is because usually companies deploy multiple times a week, if not multiple times a day. So you don't want deploys to take, 3 hours when you need to ship 5 changes in one day. So keep those build sizes small by keeping the number of packages you use to a minimum, minify everything, do bundles, all of that fun stuff. But when we say we want a fast build time, usually that means if you can start your build and go get a cup of coffee, then that's pretty fast. And then something else that we really need to tighten down on is making sure that the pipeline you have in place is the only way to deploy to production. So you don't want the situation where you have just some loose ends from previous methods of deploying to production, and people who still know about them use them. You want to make sure that the CI/CD pipeline you build is the only way to get code changes out, because this helps keep a really good level of consistency, accountability, and it just stops those weird, I don't know when this change got deployed. Like, it stops those kind of issues. And another thing that we really need to do as best as we can is try to keep all of our environments in parity with production. So that basically means you want to make sure your environments have the same configurations, maybe really similar data sets, anything that is production-like. You want to try and mirror that on staging, in QA environments, even locally if you can. But the goal is to try to keep your other environments as similar to prod as possible, so that when you're going through your tests and your audits, you're getting results that reflect the actual state of production. And this is always a favorite for developers. Run your tests locally first. I know sometimes we just want to push those changes up and get them out, but if your pipeline is set up correctly, the test is gonna fail as soon as the change gets there anyways. So save yourself a few extra minutes and just npm test before you even try to push changes to Git. And another fun thing that I know us devs love so much, writing documentation. The main point of this is so that other engineers can understand what you were doing, what the train of thought was behind a decision, when changes were made, things like that. It's okay to comment your code. Nobody's going to hold that against you, especially when you've taken a week off and you're the only person that works on an application. When somebody has to go in and put out that fire while you're gone, having those comments and any other documentation in there is going to help tremendously. And it helps you because not only does it give you a better understanding of how things work, it makes sure that when you come back to this particular thing 3-6 months from now, you can still figure out how it works really fast. So take those few extra minutes and just write some comments, whether it's in your code or in your pipeline directly. Now we'll talk about why security gets overlooked in the first place. So as you know, a lot of changes have come to DevOps and the way we deploy apps in general. What this means is that there's this new trend of shifting to the left. And basically what that means is we're trying to move as much of the testing and debugging to the beginning of the pipeline as possible. And that puts a lot more responsibilities on the developers themselves. So I've been in jobs plenty of times where I'm the one responsible for the CI/CD pipeline, and I'm sure I'm not the only one. But what this leads to is security almost completely getting left out. And there's a few reasons, as you can see. The first is mostly just because of time restrictions. When you're responsible for the bug fixes, for feature implementation, support tickets, and getting the changes out to production, you just might not have enough time to implement security in your pipeline. And it's just, there's so many other things that go into a deploy that security is something we talk about. We talk about it a lot. We hear about the data breaches and the DDoS attacks and everything. But when it comes to our day-to-day, unless there is actually time set aside in a sprint, which usually there isn't, something is going to get cut. And sometimes that's just security because we don't have as deep of an understanding of how it works in a CI/CD environment as we do in the actual code implementation. And that leads to us not quite knowing which questions to ask, which makes it hard to find answers. So there are a lot more resources now than there used to be on how you implement security in CI/CD. But if this is something that you don't do every day, it's just hard to figure out the right jargon to use to find the answers you need. And that leads to you spending a lot of time looking up concepts and trying to find code to copy and paste. So security itself isn't hard, but when it's not your primary focus, it can be really hard to find the answers you need. And something else, I don't know about you, but I don't use YAML on a daily basis. It's one of those, I'm glad it's there, it's great for what it does, but I'm not in that language enough to know the little quirks and peculiarities of what YAML does. So when I'm trying to build a new pipeline today and it needs to get things deploying to production tomorrow, I'm going to try to keep my pipeline as simple as possible, which means security is probably going to get left out. And another thing is that since there are, once you have a CI/CD pipeline in place, you're not going to be updating it all the time. You might update it once a month, and that's really often. Realistically, it might be once a quarter, or maybe whenever you release a new major feature. But having these infrequent updates means that since security was somewhere towards the bottom of your list to begin with infrequent updates, it just gets pushed off the list completely. You're just trying to go in and make the changes you need for right now. And like I mentioned earlier, there's this trend of shifting to the left, and it's bringing a lot of people who don't normally work with pipelines into that space. So again, if you're like a front-end developer, you probably don't touch the CI/CD pipelines very often. I know that I don't. So it's just one of those things that, yes, over time you'll start to understand how they work better, but in the meantime, just not quite understanding those concepts or why you have to structure a pipeline a certain way can lead to security just getting left out, because you might not know which phase to put it in, or it might add too much time to your build or something else. Without having that deep understanding of what you get when you work with it every day, it just makes it harder to figure out where to put these seemingly extra tools. But now that we know what we should be doing, why we're not doing it, let's see how they take advantage of us with those particular things. So intruders are not anything special. They're just another programmer / computer person, and they want to get into your website. They want your data, whatever. But the way that they work isn't that interesting. It's just like what we do. They use attacker tools. There's free ones, there's open source ones, there's enterprise level ones. Whatever level of tool you're looking for, it's out there. So it's really just a matter of how badly they want to try to attack your specific web application. And if you're not familiar with any of the attacker tools, I would highly advise you to go look at the Kali Linux OS. Basically, this operating system comes with basically all of the attacker tools pre-installed. So last time that I looked on it, I think there were like 50 plus attacker tools, and they're mostly all free. So you can scan network traffic, you can check for web sessions, you can hijack web sessions, pretty much anything an attacker wants to do. If you haven't properly secured and or patched your application, they'll be able to do it, and they might be able to do it completely for free. So something else that they do that, you know, in the process of trying to get changes to prod, we leave little things out that we know we should clean up. So that means maybe one of the services we use is misconfigured. Like, they're checking for every little weakness that they can find. And what that means is that anytime you leave those little changes unfixed, they'll probably find it if they're looking hard enough. So you want to make sure that all of your configurations are up to date and that you don't have any extra credentials anywhere. So something else that they do that honestly, it just happens when sometimes we're in a bit of a rush, or maybe somebody didn't look at a PR too well. Secrets can get committed into version control on accident. And yes, this is terrible, but just know that the intruders are checking all of your GitHub pages for anything that looks like a secret, a credential, anything that they think they could use to get access to your service. If it's in GitHub or Bitbucket or whatever version control tool you use, they will find it. I mean, there are tools like, if you aren't familiar with Git Secrets, it'll go through your repos and check for anything that looks like a secret or that looks like a credential that shouldn't be in there. So if you do go through your version control and you find that there are secrets, get rid of those immediately because somebody else will find them too. And then always check for extra open ports. So this might happen more on the back end sometimes, just because of the way that services get updated. Maybe you have to add an extra service and for whatever reason, it gets scrapped later in the roadmap. So make sure you aren't leaving any ports open that shouldn't be, basically. Because when an attacker is doing things like network scans, they're also scanning for open ports. And if you have an open port that's not actively being used, that means it's probably not being monitored either. So with an open port that's not being monitored, an attacker can basically just walk in and out as they please. That's one of the ways that backdoors are created. So whenever you're going through any of these major feature updates, or you're adding services, or you're making bug fixes, whatever it is, check for those extra open ports and just go ahead and close them. Check with the right people to make sure they're not being used by anything. But if you work with the project regularly and you know for a fact that those ports aren't being used, go ahead and close them. Trust me, they'll thank you later when somebody tries to attack that port and they're not able to get in anymore. And then my personal favorite is that they will actually just straight up look for vulnerabilities in your packages. So I know how much we all love the Dependabot notifications from GitHub, but they are important. When you get those kind of notifications or a new version of a package you use comes out, then you should probably go ahead and try to update. Because when they make security patches, they release complete reports on what the issue was, why it happened, how you can reproduce it, all of the details that somebody needs to take advantage of those vulnerabilities become available. That's why it's important to keep your packages up to date, because if they're not, you're basically giving people an easy entry into your application. Like, they don't have to try too hard because there's already a complete report written up on how to attack that specific thing. And it is not hard to find out which packages are used in any web app anymore. So make sure that you don't have those vulnerabilities in your packages. Now that we've gotten past all of the kind of background stuff, let's get into just some of the tools you can use in the different phases of your CI/CD pipeline. So the build phase, as you know, is where we get our code out of version control and make a build. This is where we get our artifact that gets deployed to production eventually if it passes through all of the other phases. But in the build phase, what we're checking for are those static site vulnerabilities. And basically what that means is we're checking for those out-of-date packages and libraries. We're checking for simple things like maybe secrets are still in the code, things like that. This is part of that shift left movement where we try to check for all of the issues we can before we even get to a build artifact. So some of the tools you might use would be Owasp Z, and basically this just checks for any vulnerabilities. That's what all of these tools do. They check for any vulnerabilities that will be in your code. And then there's one called Sql Map. This one is specifically to check for any SQL injection vulnerabilities. And the reason we check for this is because if your app is open to SQL injection attacks, that means that someone could directly attack your database. So that's why we try to include tools like this. And then there's another one called Arachne, and it's a great tool. It goes through all of your packages and checks for vulnerabilities. It checks for SQL injection attacks. It checks for cross-site scripting attacks. It checks for a lot of things. And I believe this is one of the open source ones. And then there's this one called Burp. This is more of a pen test, but it'll also check your application for any of those vulnerabilities and weaknesses. And if you aren't familiar with Gauntlet, it's not too much of a surprise, but it's a really, really great tool that helps you automate all of the other tools. So instead of going through the process and adding these different tools like Sql Map and Arachne into your build phase, you could just have a Gauntlet run file that executes everything from build to prod in whatever order you want. So keep that in mind when you're going through and updating your pipeline. And also, I want you to notice how the number of tools that we use decreases as we move through the pipeline. So right now, there are 5 tools you can use in the build phase. Of course, there's more than that, but the one that I really like is Sneak. Sneak is similar to Arachne in that it does the exact same things, but the user interface and the way it gives you reports is just really clean. So it's easy to integrate with any CI/CD tool. You can use it just in the browser. You can integrate it with GitHub. It's just a really well-made tool to use for this kind of security analysis. And actually, this is the one that we're going to implement when we get to our example pipelines later. So Sneak is a really good tool. It's probably my personal favorite. All right, so now that we have our build artifact and we know that our packages are squeaky clean, we can move on to the test phase. This is usually where npm test gets run just to double check you already ran it locally and nothing is breaking, there aren't any regressions, things like that. But one thing we will run in here is the Owasp dependency check. And this is another way to make sure that none of your dependencies are out of date, and it keeps you informed on how those dependencies are related to the Owasp top 10 web security risks. And then another one of my favorites is retire.js. And basically it just goes through and checks your packages to make sure you're not using anything outdated, that none of your current packages depend on outdated packages. goes really deep into your package tree. So if there's any type of vulnerability with a JavaScript application, Retire.js is probably going to find it. And then, of course, there are some enterprise tools like Type Nexus, and Vericode, and they pretty much just go through and run the same checks that the Owasp dependency check tool runs. So it'll report back any web vulnerabilities it sees, like maybe you have some broken authentication, or maybe your site's vulnerable to cross-site scripting. It'll just go through and check everything with a fine-tooth comb. And one of the reasons you might use an enterprise tool over an open source tool is just that support. Sometimes there are some weird things that come up in security testing, and you need them to be a little bit more defined. Like maybe you'll have a weird error message where there's no docs on it, and you need to figure out what that is because you're in the middle of a compliance audit. So this is where enterprise tools come in over open source. And of course, if you're working on really, really large projects, or you're working with a lot of projects, it just gives you more, I want to say more like glue. It keeps everything in one place and you don't have to worry about things getting out of date. It just keeps things cleaner when you get to that size. So now that we're out of testing, we know that our artifact is good to go. There shouldn't be any real issues left. And by the time it gets to the user, it's going to be so secure that it would take the best hacker 10,000 years to crack through it. But in the delivery phase, this is usually where we're deploying to staging, or maybe we have some edge case QA environments. Whatever. This is everything that happens before we deploy to production. This is the D part that's left out of CI/CD a lot. And a lot of people think CD just stands for deployment, which arguably it does, but the delivery phase is pre-deployment. And this is where you can run those last few checks, like any integration tests, any type of manual checks you want to do just to make sure it feels right to the user. But in this phase, there's not a whole lot of automated testing you can do, but there is one tool that makes it a little bit easier. But first, we'll start with the Devops Audit Defense Toolkit. This is basically just a PDF with a nice explanation of what you should be looking for when you do that kind of manual audit. This will help you when it's time for your HIPAA compliance audits, when it's time for any PCI audits or GDPR audits or any of the other acronym audits. This will give you the foundation for how you should build your pipeline to cater specifically to these kind of compliance regulation rules. And then there's Chef. So Chef is a really great CI/CD tool slash infrastructure as code type thing, but it has one specific thing called Inspect that particularly makes some security testing easier. So Inspect is kind of like automated compliance checking. So if you have an app that falls under any of those crazy acronyms, it might be worth taking a look at Chef Inspect just so that you could potentially add some kind of automation to this part of your CI/CD pipeline. And lastly, the deploy phase, the one that we've all been waiting for. Users are yelling for it. Product is just ready to get it over with, and we're finally here. So it's passed all of the build testing, and we have our artifact. It's passed through the unit test, through integration tests, through QA. It's ready to go, and we don't have any doubts about how secure it is. Or at least that's what we feel like. So at this point, there's not a whole lot you can do. This is where your application is in production and your customers and real users are working with it. So basically what you do at this point is get other people to try and hack your application, your live application if you're bold. And there are a few places that you can go to get some really good feedback on just security issues that come up. So one place, if you want to do more of a like bug bounty type thing, HackerOne has some great pen testers. Basically, you get to put up a bounty for any type of security check you want, and somebody will attack your application and see if they can get that bounty. And then there are these three, which are basically, well, BugCrowd is similar to HackerOne. You can go on there and post a bounty for any security checks you want. You can go on there and find the people who are really, really good at pen tests. Or you could go on there and learn how to do pen tests yourself. It's just, those two are great community resources when you're looking for stuff to double check that your live application is just as secure as you thought it was when it was in staging. And then you can go ahead and hire some pen testers. So like Signal Sciences or ThreatStack, they'll be able to take some experts that will go through your entire application and just try to attack it from every way possible. The great thing about going with an actual team is that you get these kind of reports that you just won't get from a community. They're professionals and they'll prepare that report in whatever format you need to help you fix those particular issues. So when you're in the deploy phase, you're already in production, which means if there are any security weaknesses left, they're live, and it happens. It's just something you have to be aware of and thoroughly test for. Do as much testing here as you possibly can, because it's just going to make that difference between you being the next big data breach story and you not. Nobody wants to be well known because their application got hacked. But this is just one of the ways, if you're having any doubts whatsoever about the security patches that you put up, getting an actual person to check for them will find them in a way that automated tools just can't. But there are quite a few things you can do to make sure that your application doesn't get hacked. So not all of these are in your pipeline, but they're all directly related to it. So keep your user permissions up to date. You know, the person that left the job 6 months ago, they probably still shouldn't have admin access. Go ahead and get rid of that email address. If they need it again, they can come back and get the permissions set up again. Or it doesn't hurt to go through and do just a permission audit, because sometimes you have new people come in and they don't have all the permissions that they do need to do the work properly. So you want to make sure that your user permissions don't give too much access to people who don't need it. It gives just enough access to the people that do need it. And anybody that doesn't work there anymore has zero access. And then again, pay attention to all of the security patches from the services you use. And that might not just be your application packages. It could be any third-party services you're using. So say, for example, you're using Stripe as your payment processor, and they have some kind of security issue going on. You want to make sure that you monitor that closely. Even though it's their patch to make in their application, your code uses that. That means you are also susceptible to whatever attack that they are. So make sure that you're staying up to date with what's happening with the services you're using as well. And again, make sure you don't have unnecessary ports open. This is just a way for somebody to make a backdoor and then they could close the port. Then nobody would know what happened, which does happen in quite a few cases. So you know there are tens of thousands of port numbers available. Make sure that you don't have anything extra open. Go through your node backend and check for any extra ports on a microservice, or maybe you're connecting to some different endpoint somewhere. Just make sure that if you see that grayed out code for a port number, you just go ahead and delete that because it's not being used anywhere and it's just leaving this weakness for somebody to exploit. And of course, not everybody is trying to attack your website in particularly, but say somebody is new to hacking and they just want to see if they can do it. Then they might look at you like, oh, that one's not too bad. I'm just going to try and see what happens. And boom, they found your port and now they've just DDoSed your entire system because they could. So make sure that you don't have those ports open. And then with most of the CI/CD tools you're using, they have a lot of built-in security features. So something like Conducto or Circle CI, they encrypt all of your secrets. They encrypt your environment variables. Or maybe you have a tool that makes you use two-factor authentication. It's things like that that just give you that extra benefit in security. So you're probably paying for this tool already. Why not go ahead and take advantage of everything that it has to offer? So if there are any little security features that you can just toggle a little switch and turn on, you might want to look into it and read about it to see what it actually does. And if it fits something that you're looking for, just use it. You don't have to go through the process of making your own tools or adding a bunch of different tools if they do it for you already. And something else that you might want to consider is using an IAST security tool. Basically, what this does is that as your code goes through your pipeline, it will alert you anytime that there's a vulnerability found, or maybe you were checking for cross-site scripting and it was actually able to execute a script. This will send you a message in Teams or on Slack. Maybe it'll add a ticket to Jira or Trello, whatever you're using. This helps you to keep track of all of those little bitty issues. What happens is a lot of times we get this giant report at the end of a pipeline run, and let's be honest, nobody's really looking through that. We'll check and see if there are any errors or warnings, but nobody's really going to read that entire console output. That's why an IaaS tool is so valuable. It'll take the particular issues that you configure it to look for, and it'll push them somewhere where you're gonna look. You're gonna find these things that it's telling you are problems. And then make sure everything is encrypted. Like at this point, you can use the crypto package and encrypt all of your JavaScript stuff. I know there's a bunch of crypto stuff on the back end. Just encrypt everything. If you're not using HTTPS, I'm not quite sure how you're getting past Chrome stuff, but you should probably think about updating. So just make sure everything is encrypted. That way, if something does get intercepted or attacked, it's a lot harder for that entity to decode it and get the information they're looking for. And then the easiest thing is probably keeping an eye on that Owasp top 10 list. This will tell you all of the vulnerabilities that you should be particularly concerned about. An interesting statistic I found out just from going through the Owasp top 10 list is that 60% of websites have some kind of security vulnerability. That's pretty crazy because there are a lot of websites out there. And then another thing that sounds kind of obvious, but we do overlook it, use the same tools attackers are going to use. If you have even the tiniest interest, I so suggest you go check out that Kali Linux OS, because that has pretty much all of the tools any attacker could ever need. And it'll give you a good idea of how they're trying to attack your system so you can protect it better. But now we're into the fun part. Let's look at some code. So first we'll look at a Sql CI example. And as you probably know, we have our Sql CI folder with this config.yaml. Basically, we're going to use sneak for our checks. So we have this sneak orb, and it's that version. But the interesting part is when we come down here. So right before we run our tests and our build, we do this scan to check for any vulnerabilities that have a really high level, and then we're not going to make the pipeline fail when it finds these issues, because that would just slow down that deploy process way more than it needs to be. We'll just get a report and send it to whatever tool it needs to be sent to. So these 3 lines, that's a whole security check right there. It doesn't take a whole lot except some familiarity, and that's, again, why it gets left out sometimes. Security is not necessarily hard to implement, it's just hard to carry over. But now we'll look at one for Conducto. So Conducto is a little different. It's not written in YAML, it's written with Python. But basically, after we install all of our packages, you can just run sneak test. That is it. You just did an entire security audit. Well, not the whole audit, but you did a really thorough security check just with this one part of one line. And it gets run right when things are installed. And then you go through your checks, and yeah, if there's any more security tests you want to run, you just add the command line for it, and it gets executed. And the last example we'll talk about is Travis CI. So we just have our .travis YAML. It's really, it's a weird combination of the Sql CI and Conducto pipelines, at least in how we use sneak. So in this case, we install a bunch of stuff. So this is where we'll run npm I and whatever else. And then we just run sneak tests like we did in the Conducto pipeline. So the main reason I wanted to show you these 3 different tools is just so you see it doesn't matter which one you're using. The tests are just as simple to implement across the board. The only one that's a little bit more complex and will take you some reading is probably Sql. But with that being said, let's just go to some key takeaways so that you have your little backpack of CI/CD security knowledge. Keep your secrets safe. Don't let anybody check those into your version control. If they have a commit with the secrets in it, well, I'm sorry, they should probably get rid of it. But make sure your secrets are safe. Use git secrets, and that will do a quick scan to make sure you don't have anything already in GitHub. And then whenever your projects are going through any major updates, so maybe it's a new feature release, or maybe you're changing from one package to another, or like with a big refactor, just make sure that you go through and do a quick CI/CD audit to add any tests that are missing, to maybe run some stuff in parallel instead of in series, just give your pipeline that tune-up whenever you give your code one of those major tune-ups. And then check that you have updated all of your packages, check that all of your services have updated their packages. Anything that should be patched should already be patched. So make sure that none of the things you are using still have vulnerabilities to known attacks, because there's entire PDFs written about how to exploit those. And the last thing, don't be afraid to try new tools. I know it seems like, at least for me, it always seemed like hacking was this just crazy other skill, but it's really just knowing how to use the tools and read the data like anything else. So don't be afraid to try new tools, whether it's learning what hackers use or whether it's a new CI/CD tool. Just keep in mind that new tools come with things that the old tools just don't have. And sometimes that's a good thing. But yeah, that's the end of it. So if you have any questions, feel free to ask me.
Yeah, in the Discord channel, please, or here in the Q&A. I had a question, Malaysia. I was curious. You recommend encrypting everything. That's a pretty big topic. I was curious if you have any recommendations for specific encryption algorithms or salts, way to do that, or specific key lengths or anything.
One thing that I have seen, just like from a security talk, is that key lengths should be at least 44 characters. I think it has something to do with like the SHA-256 encryption. I know if you're not familiar with like the Pixie auth flow, it uses the SHA-256 encryption, and then it encodes it in some base64 URL thing. And that helps to make like at least authorization requests less susceptible to like session hijacking.
That's like an encryption. That's the level of encryption that's happening while you're transferring your data, right?
Mm-hmm. So maybe that's a little overkill for everything, but probably at least some SHA-256 or whatever the crypto package uses.
I was curious because yeah, on my project we had to do the encryption at rest thing,
Mm-hmm.
And we had a bunch of different tenants, and we chose a salt based on the tenant so that each tenant had a separate encryption. And we originally chose SHA-256 because it seemed like that was like the standard, and it turned out to be really slow. And
Mm-hmm.
we went back to 128 a
Mm-hmm.
qubit length, and I don't know. I was always just a little bit nervous, like, oh man, are we? Is that like a security risk or whatever? But we needed to for performance, so.
Right.
I don't know.
Yeah, that's one of those. I don't think the 128 version has any major issues at the moment. I don't think so.
Cool. Hal says, Militia, great presentation, a lot of takeaways. So, yay, thank you.
Yeah, thank you. I'm glad I could come.
All right. Any departing thoughts, or looks like?
I guess the main thing is just make sure you consider security in general, because it is something we tend to forget about until the end.
Yes. Yeah. So true. All right. Well, thank you again.